Hi everyone, welcome again to DLC series of tutorials. In the previous video we discussed decorators, now we're gonna discuss multiplexers. So the basic idea of multiplexer is that you're gonna give the selector, the value of selector, and based on the value of selector, you're gonna get the value of the function. For example, here, if the value of a, which is a selector, is 0, okay, if let me write it here. If a is 0, then the value of function is going to be v1, v0. If the value of if value of a is 0, so if it's 1, the value of a is going to be v1. So the value of f function depends on the selector, which is the a. This is a selector, right, as I've written here. So this is a 2 to 1 multiplexer because you have two values and one output. So the number of selector is always 2 times less than the number of values. So if it's 2, here 2, then the number of selector is 1. So for example, let us now consider 4 to 1 multiplexer. Here, as you can see, we have what? We have two selectors, A and B. So if I have two selectors, two variables, so that means there is 4 combinations, right? When the value of A is 0 and B is 0, when the value of A is 0, B is 1, right? This is the first case, this is the second, right? Third case, and fourth case, right? So you have two selectors, that means you have 4 values. Because two selectors, 4 combinations, and you have value for each combination, right? So if the value of A and B is 0, 0, right? You have, the function's f value is v0, right? If 0, 0, v0 is going to be the value of f and so on, right? If the value of a is 1 and b is 1, the value of f function is going to be v3, right? v3. So this is very, very simple, right? So as I've told you, value of the function depends on the value of multiplexer. Sorry. The values, let's say the values, because you can have more than one selector. So value of selectors, right? Okay, please just remember this. So now we're gonna do what? We're gonna consider a problem where then we have to implement the function now, not using decorator, but using multiplexer. So you're given this function, f equals to w1 not, okay, w1 not, then w3 not plus w2, w3 not plus w1 not and w2. Your task is to use truth table tt to derive circuit. Firstly, you're gonna use truth table, okay, to derive circuit that uses 2 to 1 multiplexer. Okay, so what we're gonna do is that we're gonna find firstly find, if you're gonna have this kind of question, please just firstly find truth table and then implement the function based on truth table using 2 to 1 multiplexer, big M. So oh my god, we're gonna use this multiplexer, okay? First one, shortly it's like that. This is multiplexer, 2 values, 0, 1, values of selector, v0, v1, the value of the function. If the value of a is 0, function's value is v0. if the value of a selector is 1, function's value is 1. So let's come back. So before this, we're gonna we need, okay, truth table. So firstly, let's write here truth table. So here, so v1, w1, w2, w3, the value of f. So as you know, 3 inputs, so that means we're gonna have 8 combinations. So 0 0 0 0 0 1. Okay, let me quickly write 1 0 0 1 0 1, and finally, no, not finally, 1 1 0, and finally 1 1 1. So you know, in order to find the value of function, what you're gonna do is just substitute the value of w1, w2, w3 here in this given function with the value of the w1, w2, w3 inputs in each row. So firstly this one, put here, I mean everywhere 0 0 0, then you're gonna get the value. So I done it beforehand, so thus I'm going to write the values of the function for each corresponding set of inputs, right? Now without calculating, without showing it, because it's really simple. Just substitute the values in each rows and you're gonna get the function's value. So it's gonna be 1 0 1 1, and then the 0 0 1 0. You're gonna, I mean, you may check it yourself too. So now let's analyze the truth table. You know, it's not just finding truth table. You know, in this kind of questions, when you are asked to use truth table to derive a circuit, do you understand me? We're gonna use truth table to derive the circuit. I mean, we now kind of build truth table. This is called building process. Now we have a truth table. Now we have to derive the circuit. Okay, so this is very important step. This is the second step of the first step. I mean, this is the first step of our solution. The first step of the first step, finding truth table, we kind of done. I mean, we built truth table. Now we're gonna derive the circuit. So in this particular case, you have to analyze the truth table and find the common case. What I mean by common case is that, for example, you can see that in the first 4 combinations, the value of v, w1 is 0. So let me use different color. See? And in the next combination, it's 1. Okay? Do you see it? So, you know, we have multiplexer. I mean, we're gonna use multiplexer, right? So please think logically. It's very important. We're gonna use multiplexer. And I told you that in multiplexer, the value of function depends on the value of selector. So if you want to derive the circuit that uses multiplexer, firstly, you have to find, or you have to identify what input is gonna be selector, okay? So let me write it here. Firstly, build truth table. Then analyze, I am just first, let's kind of do write this numerization like on a Tom square. Okay, so build truth table and then identify selector. To be more precise, which input is selector. So we have 3 inputs, right? I mean, V1, W1, W2, W3. So yeah, we are in the second step, and it's understandable for I guess our selector is going to be W1, because you know we have the common case for 4 combinations. W1's value is 0. For rest of the combination, W1 is value is 1. So as you know, let me go upper. As you know, in selector we have what? two values specified for the selector, 0 and 1, so our job is done. So now what we're gonna do is just to draw what? To draw multiplexer. So I'm gonna draw multiplexer here. It's gonna be this one. So this is a multiplexer. What here we're gonna specify the selector, which is W1, and here the F01. So now you know, we have here, of course, we have here V0, but V1, but this is not just always kind of one input. What I mean is that here, instead of V0, there can be any kind of circuit, for example, this kind of circuit, you know, and gate, this OR gate, you know, and they are connected together with AND gate, and this can come here, okay? So this can be V0. I mean, you're not always gonna have, I mean, just this given input 0 or 1. Instead of this V1, V0, there can be circuit. And this is a case. I mean, here we have to not just write V0, V1, but here we're gonna do what? We are gonna kind of build a circuit. I mean, I'm gonna show it to you now. So let me delete it. What I mean is that here, please be careful. See that we have 4 cases, right? I mean, in the first case, when the W1 is 0, we have this. Oh, what I done? We have W2 and W3. So, I mean, using this input, we're gonna build the circuit. Okay. So let me quickly write it here. So W2, W3. So 0, 0, 0, 1, 1, 0, and 1, 1. And what gate is gonna be this one? So when the output is 0, 1, 0, 1, 1. So now we have to identify what gate should we use when, for example, 2 inputs is 0, function is going to be 1. Okay, when W2 is 0 and W3 is 1, the function's value is 0. So let me think. Okay, if you think, you'll come to know that one of them should be negated, right? Yeah, one of them should be negated, but you know, you can just identify the gate, the gate, or gate, just analyzing this first case when V1 is 0. Now you have to also analyze the second case. So because it's just impossible, kind of identify which gate you're gonna use just for this input. So let's also write the rest of the case. When the value of V2 is not V2, but when the value of the W1 is 1. So when the selector's value is 1. So this is gonna be what? This case, this one's. So when 0, 0, 0, 1, 1, 0, 1, 1. So 0, 1, 1, 0, 0. So now let's analyze. So okay, so it's pretty clear that if you have 1, 1, and 0. So I guess this case is gonna be AND gate, and this case is gonna be, I guess, OR gate. When the selector's value is 0, is gonna be OR gate, and when selector's value is 1, is gonna be AND gate. So now we have to identify, is it gonna be just W2 and W3, or one of them will be negated? This is the question. So let's see. For example, let's see this one. If it's gonna be AND gate, if you have just 1, 1, it's not gonna be 0, it's gonna be 1. So either of them, one of them should be negated. So let's choose W3. Okay. So and then let's check this case, all case. So when W2 is 1, and when w3 is 0, it's gonna be negated, right? I mean, let's just what I'm doing. So instead of this negation, this bar, instead of this bar, so just wait, instead of this bar, let me use this negation. So w2, w3. So when w2 is 1, this is going to be 0, right? I mean 0, but overall it's going to be 1 because there's negation, so this produces 1. Okay, so this is correct. So when the selector's value is 1, okay, when the selector's value is 1, we're gonna have AND gate, and the inputs are what? W2 and W3, but here we have negation. So again, I'm sorry. So let me draw, I mean, a little big. Why am I drawing so small? So I mean, I hope it just you understand that this process kind of requires some thinking. So you have to kind of consider two cases for the selector when the value of selector is 0 and value of selector is 1, and analyzing this two set of the combinations, you have to kind of guess and check. I'm guessing here that there is the AND gate and there is the OR gate, and I am checking whether it's true or not. So by guessing and by checking, just putting these values and testing, you're gonna identify a case. So here it's gonna be AND gate. So here, of course, you know, if here is okay, here is AND gate. So now there's a question about here when the value of selectors is 0. What we're gonna have. So let's consider this case 0 0 1. So again, one of them should be negated, right? Because I mean, when inputs are 0 and the operation is OR, you're gonna get always 0. But in this case, you're getting 1, so one of them should be negated. So again, let's choose that it is W3. So I'm checking this, our guess. My guess is that the operator gate is OR gate, and W3 is negated. So I'm putting the value here, 0. Okay, this is 0, and this is 1. So this is 1, but this is negation, right? From negation it's going to become 0. So overall, it produces 0. So this is correct. So those, let me redraw the circuit here. So, okay, we have W2, we have W3. So this has become negated because for both cases, W3 is negated, right? I mean, here. So then we're gonna have here AND gate. So from here we have 2 coming, W2, and here we have, from here we have W3 is going here, and here we have OR gate, and this is connected to the case when W1 is 0. So overall, I hope you understand that. Firstly, I hope you understand that what multiplexer is. The value of multiplexer depends on the selector, right? So then if you're gonna have the question where I kind of use a truth table to derive the circuit, the very first thing you're gonna build the truth table, and then you're gonna analyze the truth table. And analyzing means what? Analyzing means identifying the second step, what input is gonna be selector, and then you're gonna analyze the blocks, two blocks, in the case when the selector's value is 0 and 1, I mean, as we did here below, right? This is the 2 blocks. First block, when the W1's, selector's value is 0, and the second block. And out of analyzing these blocks, you're gonna guess and check. What I mean by guessing, you're gonna guess what gate you're gonna use, okay, for this blocks, this block and this block, and you're gonna also kind of guess and check whether inputs are gonna be negated or not. So by testing, by guessing, you're gonna find the final circuit. Okay, so finally, this is kind of V0 and this is, let me choose a different color. So firstly, let me delete this one. So actually, this is what? This is V0, this is V1 from here. Yeah, from here, right? But not always you're gonna have just two inputs. Most of the time, you're gonna build such circuits, okay? And you're gonna build such circuits by doing what? By, okay, let me write here, by guessing and testing gates, okay? And by gates I mean not only this gate and this OR gate, but also if the case when the input is negated or not. Okay, so negations, next, and OR gate or AND gate, etc. So I hope this series of tutorial was understandable for you. So if you have any kind of questions, just please feel free to ask. But I just suggest you to kind of open the book and solve some examples so that it can become more understandable for you. So thank you for your attention.